Well, I've wanted to play with one of these for a while now, and Camplux was kind enough to send one to the channel for us to have a play with and take apart. I apologise if it's windy in the microphone and the lighting's not great down this end, but we're going to probably get wet, so we're outside. I shall give you a brief operational guide and then we'll put it on the drift bench and take it apart. Okay, on the front of the shower is the gas control heater, maximum gas, minimum gas, water flow, maximum water flow, minimum water flow, and this is the output temperature that it displays. And on the underneath you have your gas pipe in. They give you a gas pipe and a regulator, and it runs on propane, or well, patio gas in my case, but it's still propane. Just for the interested, at the moment of the time of this video, 13 kilograms of propane is £48.50. The red line, unsurprisingly, is the hot water output. They provide you with this nice shower head, just got 3 positions of shower head type and an on-off button. This stop button here that's kind of leaking a little bit, but oh no, it stopped leaking now that I've pressed it a bit harder. Excellent. And the other side is blue for the cold water feed. I have mine connected to the garden hose for mains pressure. And the last bit on here is the battery compartment that contains 2 D-cell batteries, and that's what it runs on. 3 volts supplied by 2 D-cells. That's it. You connect the water up, connect the gas up, and as soon as you turn on the shower, lights, and away she goes. Okay, let me show you that. Panning too fast. Here is said shower head. I shall turn it on for you by pressing the back of the button. The thing has lit, and there's the temperature display. It should now hopefully climb. 26, 27, 28, 29, 30. So I've got it set to minimum gas and minimum water pressure, and it's quite happily doing. Well, there's 34 degrees. Is it going to go to 35? 35, and this is the level of pressure you've got. It's real shower pressure. I'm trying to do this one-handed and it's not working. No, that's it. Spray everything. Middly mode, pointy mode. Yeah, shower mode. That's pretty much household shower pressure, and well, we're up to now 37 degrees. So basically, just to adjust the temperature, you either turn the gas up and down, or you can turn the water up and down, or both, and you get a combination. And well, to stop it, you just press the stop button on the shower. Stops, gas goes off, and it stops being a shower anymore. And that's it for operation. There's no high-tech shizzle whizzle on that. Yeah, don't set your shower head upside down onto the start-stop button. Idiot. Stop. Please stop sitting it on that side. Just lie there quietly. Beautiful. Yeah, right, that's it. Let's take it apart now. Now, in an effort to not scratch the ever-living fuck out of it, I have put the towel down. Now, as I don't have any bright orange towels to match the channel colours, I've decided to borrow Big Clive's colours for the day and gone with shocking pink. I think it's just a few screws around the top, 2 there, and that lets it lift off the panel. So, allow me to shuffle it this way a tad and remove the screws from the top. So I was taking the screws out around the top and they felt quite tight, and I think these are the tri-lobe versions where it's almost like a triangle shape and 3 of the sides the threads are squashed, so when you put them in, tighten them, they stay in, they can't rattle out and they can't ever come back out. Right, I've also turned on backlight compensation on the camera, so hopefully this image should appear brighter now that we've started doing things. And will my reflector still wash the thing out? A little bit. Let's turn the video light back off. Right, that's 4 screws across the top. Try not to lose them just yet. Come on now. Are you ready? Dun 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 dun. Dun. Right. Hopefully I can. Oops, I have popped them off though. Okay, they just pull off, that's fine. It's not made my life any easier. Remove top flap. Ha! Nice. And are they long enough to let you flip it all the way over? No, they're not. So there are 2 plugs to unplug. Of course there are. That one and that one, which is just the one is the well, actually they're both the display. Whew. That is a lot of aluminium tape that's just kind of stuck in some places. Wow. I mean, would it really have taken somebody an extra 30 seconds to actually make sure like all the edges were stuck down? Like, at all? Properly? I mean, it's just aluminium tape. How long did that take me to stick all of that down? Really? People. No, actually, let me just put that over there. Out of the way. Well, there we go. Or here we are. Move this out of the way as well. Right, sit on the floor. I'll sit there. Let me bring it around. Well, this looks like every inside of every boiler I've ever seen ever. Allow me to start with the bits I don't like. My first bit I don't like is this battery holder down here. Let me bring you in on the battery holder. So the very first thing I did with this battery holder is, as you can see, the batteries are held in place by these tabs, except this tab's no longer there, because the very first thing I did trying to get the batteries back in it was to snap these tabs off. And this is the only on-off switch there is. This is the on-off switch. That's it on, that's it off. There are literally 2 terminal connections on the back. They could have put a switch in next to the display in the front and just had an on-off switch on the front as well. I say, like, where's the hard thing? Like, there are 2 wires here. This white thing wire, that's your battery power supply. It goes all the way over to the control box over here. You could have just made a switch in the front of the display and had it turn on and off. And then that wouldn't have been a problem. You could have just left the batteries in it, left the thing closed and just turned it off. Granted, it adds an element of safety that you know it's off because, well, the batteries have fallen out it. But, yeah, anyway, it's just me. Right, let's start down here, shall we? So, here is the gas in, and here's a solenoid valve, an electronic operated solenoid valve that turns the gas on and off. We've got a micro switch here. Now, this operates on when you turn the shower on, it senses the drop in pressure and then opens the gas valve, lets the gas in, lights the gas, heats the water up to your temperature that you've twiddled your dials on. By twiddling the dials, I mean you adjust your water flow rate in and the amount of gas you want to burn, and that lets you adjust your temperature. So you either have a lot of water pressure and then you can turn on a lot of gas and have hot water, or you can turn on a lot of water pressure and use less gas. Personal preference. You will get the same temperatures depending on how you do it. So gas in, and you've got gas solenoid into gas burners, burn hot water. Cold on the blue, in here, adjustable valve, in there, up there, round, and then round the preheater, and then through the actual heat exchanger itself, back down hot water. So back down here, and then back into this outlet, with the red for the hot water pipe, and this might be, it's either the temperature sensor or it's the pressure sensor to sense the drop in pressure. I do not know which. Cannot identify it from the wiring. That's a micro switch there. Now that micro switch might be the pressure drop sensor. I'm not sure. That might just be temperature, that might be pressure drop. Mechanically activated when the pressure drops, it opens the switch, because we must have a 3 position so it can sense open and closed. Not entirely sure how that works, but the principle is it needs to see water pressure on both sides and sense the drop for it to actually turn on and light it. I don't think it cares whether the gas is attached or not. It'll still open the thing, and if it doesn't light, it doesn't run and nothing will happen. Right, let us take you off for a view inside the burning chamber and other bits. Right, let's put the light on. Oh, sorry, I should have said I took this bit off. This is just a cover that covers the intake bit there. That is your igniter. You can see the igniter there, and it's the bit on the burner head where it ignites to. That should be the thermocouple that lets it know once the flame's hot and established, it can turn the igniter off. This bit here with all the pipe work, that is the burner. And all those wrinkly bits in there is where flame would come out of. Your flame then mixes with oxygen and burns inside there in the chamber. And up there you can see the heat exchanger. And on the outside, so that's the cold water pipe coming in through your valve. Then it joins on and does several loops of the mix chamber where it can get preheated, so you're absorbing any waste heat generated in this area. And then it goes up in here and into the primary heat exchanger where it gets the most hot gas and the most burning. And then it leaves there and exits through this pipe here, this pipe. And that's either a thermal cutout or a temperature sensor. I do not know which. Possibly a thermal cutout. If it gets too hot, it turns off. I don't know if it's got smarts that much. That might be a testing video for another day. Hot water comes down and leaves. And let's just say that's probably a temperature sensor, and that's probably the pressure drop sensor. And your hot water comes out of your gas in. Hot water, cold water, and the battery. Yeah, that's the bit I don't like. There's my snapped tab right there. One snapped tab, one kept tab. Also, that stabs into my batteries. Like, your batteries have got this plastic wrap on the outside, and the one I put in there, that stabbed into the battery and I couldn't get it to come in or out, and it just snapped off. So yeah, that bit's not so great. I mean, it's just a positive and a negative up here. We could literally put in our own 3-volt power supply. You could make a 3-volt power supply on a plug, and then, because I know the question's going to be asked. Can I put it in my camper van? Well, you can do whatever you want. It's you. You're the master of your own destiny. You're not supposed to put it in your camper van. It's supposed to be for outdoor use only. But that's because it is a gas burning appliance, and carbon monoxide will kill you if you're stupid enough to let it kill you. Right, I'm going to put all that back together, and then we can talk about it some more. There we are, she's mostly reassembled. I've just got the top plate to put back on it. Oh, and there's a fancy aluminium chimney that goes on the top of it. Hold on, I'll go and get it. It's your typical stainless steel type wind guard where hot gas goes in there and then escapes down and out the sides, just so it's got a bit of wind protection so the wind doesn't blow down your chimney and blow it out. Now, what are the specifications for this bad boy? What have we got? Type of gas, G3031, which is, I think that's propane, is it not? Minimum gas pressure, 25 millibars. So it says propane, but it's got a G30 and G31, which I think is the two propane butane. Is it propane butane? Yeah, you can leave a comment and let me know. Data size. Nominal heat output. So this is a 20 kilowatt burner. So if you compare the little Webasto diesel heaters, they are 5 kilowatt-ish outputs. That's 5 kilowatts. This is 4 of them that's 20 kilowatts. That's more than my home electric shower, which is a 10 kilowatt. And this is, it's got an efficiency on it. So it's 90% efficient. So for your, however much gas you put in, you're extracting 90% of the energy for that. I don't think the Webasto's are quite a 90% efficiency. Power supply, 3 volts DC, and water pressure range is what is that, maximum? 8 bar water pressure? 8 bar water pressure? Nominal hot water producing capacity, 10 litres of minute with a delta time of 25k. Is that 25 Kelvin? 20, so it can heat 10 litres of water per minute by 25k. Okay, I'm going to need to write that down. So it's nominal heat output of 18 kilowatts of your 20. Okay, minimum heat output is 12.8 kilowatts. So if you've got the gas at its lowest, call it a peep, put your gas at a peep, it's just under 13 kilowatts of power. Blah blah blah, mass appliance must be protected from rain, very hot. Yes. So, people will ask, can I put this in my camper van? Well, of course you can. You can do whatever you want. The main reason it says it should only be used outdoors is it's not sealed. So your domestic boiler in your house is completely sealed. The air intake comes from outside and the exhaust gas leaves outside through the wall, and none of it enters your house at any stage. There is no air drawn in through your house, none of that. I'm assuming, of course, talking about a modern combi boiler, not an old I don't know, an old boiler, because yeah, that's true. They worked similar, but yeah, let's not go into that. They're completely sealed on the inside of your house, so this always burn when it's in your house, it's burning away, and no carbon monoxide should ever enter your house. And that's why you have carbon monoxide alarms, because if they go off, then your boiler's got a problem, it's leaking in your house, and you need to stop using it. This is not sealed, as we see, in any way, shape or form. There is a big fucking hole in the bottom, side vents, and the top vent just vents the atmosphere. So there's nothing to stop you though, like mounting this on the back door of your van. You could mount it on the back door of your van, open your door and have a shower cubicle at the back of your van. Therefore you're still using this outdoors and that way. You could, of course, you could build an enclosure in your van, a completely sealed enclosure in which you're drawing air from outside into your enclosure and you vent that back out through the roof or whatnot, so that if there is any carbon monoxide, it never mixes with the rest of the van. But again, this is a shower and you're not using it for heating up water, so you wouldn't go to sleep at night with this running. You would only be using it when you're active and awake, because that's why carbon monoxide kills you. It's when you're asleep and the carbon monoxide poisons you when you're asleep and you don't know you're being poisoned and then you die in your sleep. When you're awake, you get nauseous, vomiting, headaches, all of the other symptoms that you realise, I'm being poisoned at the moment, but you don't get that when you're asleep. So even if you were to use this in a confined space and you were to get carbon monoxide poisoning, you would notice, because like I say, you would have nauseous, blood vision, headaches, vomiting, etc. And then you would leave, go to clear air, and stay there until you feel better. But yeah, you shouldn't. Like I say, this says for outdoor use only, so you should only use it outdoor. But you are the masters of your own destiny, and you can do whatever you want. So I'll leave a link to that, an Amazon link in the description. You can go and look at it, but it seems reasonably well made. It works. I mean, like, all I did was give it gas and water and 2 batteries and poof, hot showery water and 20 kilowatts of hot showery water instantly. And that's the thing. It's instant. Literally within 2 or 3 seconds, you've got hot water. You don't have to fire up your diesel heater, run it for 10-15 minutes to get it up to temperature. None of that. It's instant hot water is its thing. we'll probably run further tests on it, like torture test it later on in another video. We'll give it as least amount of water pressure as it can handle and see how hot the water gets before it turns off. We'll do that. Any other comments, questions, suggestions, etc., leave them in the comments down below. And as always, thanks for watching.